in the 13th century, there was a mathematician by the name of Fibonacci that came up with something called a Fibonacci sequence. Like most mathematicians, he was looking for patterns in mathematics. And he noticed that if you arranged a sequence of numbers so that one number added to the next number gives the next number, you got a rather unusual pattern. 8 plus 13 is 21. 13 plus 21 is 34. 21 plus 34 is 55, and so forth. That's called a Fibonacci sequence. If you divide the smaller number by the bigger number in each case, you get a ratio of 0.6. It is sometimes called pleasing rectangles. If you make a rectangle that is using a Fibonacci set of numbers, like 8 by 13, it is aesthetically appealing. If you made it 8 by 15, it would not be aesthetically appealing. People wouldn't like it as well. So in Architecture 101, we know that using rectangles that use the Fibonacci ratio is something that has some advantages to it. Another interesting thing happens with this, however, that is truly remarkable, and this was another part of Fibonacci's work. If you cut a square off a Fibonacci rectangle, what you get is another Fibonacci rectangle. So in this diagram, if you took the rectangle that is lying horizontal and cut the square on the right off, what you would have is a Fibonacci rectangle, in this case, which is vertical. And it would have the same ratio, the 0.6 still holds for it. And if you cut a square off of that, you would get another rectangle, which is in the bottom left corner, and it has, again, the same kind of ratio. And what Fibonacci did was that he connected the corners of the squares and ended up with what is called a Fibonacci spiral. And we use Fibonacci spirals in architecture. Humans find it particularly beautiful. But you know what? Apparently the creator of the universe thinks it's pretty neat also, because the Fibonacci spiral is used an incredible number of times in the natural world. When we look at a spiral galaxy, the arms of this galaxy fit the spiral curve perfectly. The curl of the wave matches the Fibonacci spiral. If you watch water go down the drain, it goes down in a Fibonacci spiral, and you say, well, all right, that's a gravitational something or other. No. Because in weightlessness, the same thing happens. Subatomic particles curl with Fibonacci spirals in zero gravity. When you have buoyancy counteracting the gravitational forces, you still end up with the spiral structure. And it's interesting to realize that that's true in modern fossils as well as the ancient ones. And you can see it in the snail in your garden. When you look at the curl of the teeth of a groundhog, the teeth curl in the Fibonacci spiral. When you look at the curl of the teeth of a grizzly bear, it curls with a Fibonacci spiral. When you look at the beak of every bird there is, they all curl with a Fibonacci spiral. The horns of animals, the modern animals or extinct animals, they curl with a Fibonacci spiral. The curl of the tail of a chameleon is a Fibonacci spiral. The petals on a magnolia or sunflower seeds or pine cones all curl with a Fibonacci spiral. You see the tubers of pumpkins and potatoes and tomatoes. They all curl with a Fibonacci spiral. A fingerprint has Fibonacci spirals in it. Are you picking up a pattern here? Now it's important to understand here that there is no logical reason for this. The Fibonacci spiral is not stronger than other geometric shapes. How are you more fit because your fingerprint curls with a Fibonacci spiral than you would be if it didn't? What's natural selection going to work on? You look at the proboscis of a moth, it curls with a Fibonacci spiral. You look at the feather duster worms on the floor of the ocean, they rake plankton out of the seawater with fronds that are wound in a Fibonacci spiral. A spider web curls with a Fibonacci spiral. The little structures inside Chlorotella algae curl with a Fibonacci spiral. The limbic structure of the human brain has Fibonacci spirals in it. There are an incredible number of illustrations in nature. And there's no strength advantage. There's no evolutionary advantage. But maybe there's an explanation outside of science. I suggest to you God in the creation many times has done things not because they were necessary, but because they gave incredible beauty. They gave incredible aesthetic value. Fibonacci's ratio, example of architectural design.